Hi future doctors, welcome to the next class. In this class we will discuss about Pascal's law and buoyancy force. So what is the Pascal's law first of all? So in a beaker, whenever liquid is going to be at rest position. So all these cases we are discussing when liquid is at rest position, it is not flowing, isn't it? So water in water bottle, isn't it? So water in tank, like that. It is not moving anywhere. So if you have given small amount of pressure on the surface, then what he said means how much amount of pressure you have given on the surface, it will be transmitted throughout the liquid without any diminish. Diminish means without any decreasing, it will be transmitted through entire liquid or fluid, isn't it? So this is the Pascal's law, he said. Let us assume I am applying 10 pascals of pressure. Then this 10 pascals will be transmitting to each and every point throughout the liquid. So by using this principle, by using this law, hydraulic lift, hydraulic jack, hydraulic press, all these are going to be working. Hydraulic lift. So if you are visiting car servicing center, this car is going to be lifted in hydraulic brakes. So this process is going to be useful. So if you are taking liquid like this in a vessel which is at rest position, so if you are giving small amount of force for this, so this force acting on this area. So you are giving some amount of pressure on this area. This pressure will be transmitted throughout this liquid without any diminish, and it is going to be lifted or shifted a car which is available on the next area. It is going to be A2 by applying some amount of force F2. Now finally, how much pressure you applied here? Same amount of pressure according to Pascal's law. So therefore, P1 is F1 by A1, P2 is F2 by A2. You should take different area. Otherwise, same force is going to be coming. Then what is the force acting on this? A2 by A1 into F1. They are going to ask problem on this equation. In hydraulic brakes also. So brake fluid we are going to say in autos and in cars, in the bus, lorry, in every vehicle they are going to use brake fluids. Whenever we are applying gentle push on the brake, it is going to be transmitted through that fluid. If fluid is not there, means if you are applying brake also, it cannot stop. So this is the use and application of Pascal's law. Now what is the buoyancy force? So what is the buoyancy force means? If you are taking any object within the air, let us assume you are taking water bottle. So this water bottle, if you are holding like this, you will feel little bit weight. But if you are taking this water bottle inside the liquid, so take some water within the bucket or beaker. If you place this water bottle with water within the liquid, then you will feel little bit weight is going to be less. Why? Because liquid is going to apply some amount of force in upward direction. Then only you will feel this is going to be little bit weight is going to lose, or you will feel it is little bit weightless. But whenever it is here, it will be, you will be feeling more weight. But whenever you are placing on the liquid surface will apply some amount of force in upward direction. That force only we are calling it as buoyancy force. Now how that force is going to act within this liquid? So if you are taking, this is the liquid, so within that one vessel is going to be taken. So it is at a height or a depth h1 from the surface, it is at a depth h2 from the surface. Then how much force is going to act on A and B? What is the force difference means? Pressure acting on this P1 or PA is equal to rho G H1. So pressure acting on the bottom surface PB is equal to rho G H2. So area of cross section of this surface base area is going to be A. Then how much force is going to act? Pressure is going to be F by A. So FA, force acting on the surface A, here A, or 1 and 2, that is our wish. So PA, pressure acting at A, that is going to be rho G H1A. Same like that. PB is equal to FB by A. Then FB is equal to rho G PBA. In place of PB, FB is equal to PBA. In place of PB, rho G H2A. So finally, what is the net force? Net force is going to be FB minus FA. What is FB? Rho G H2A minus rho G H1A. So rho Ga common, H2 minus H1. From the diagram, what is H2 minus H1 means? Small h. So rho Ga into h. So area into height. So this vessel is having A area, H height. That is going to be area into height is going to be rho Gb. This is nothing but buoyancy force equation. So pressure is going to be rho Gh, buoyancy force is going to be rho Gv or rho Vg. So therefore, for our convenience, we will write this from now onwards dlvg. What is this rho means here? Density of the liquid or density of the fluid. So to not to get confused, sometimes sigma, sometimes rho, sometimes d they will write. Therefore, dl means so density of the liquid. V means volume of the object. G means acceleration due to gravity. Again, buoyancy force is going to be changing according to these terms. If G is changing, then buoyancy force will be changing. So same beaker, if you are taking into space, in space G is 0, buoyancy force is 0. Same beaker, we are lifting in a lift upward direction. Then in place of G, G plus A. Lift is moving downwards. In place of G, G minus A. So like this, we can write continuously. So now, buoyancy force is depending on density of the liquid. It will not depend on mass of the body. So in this, you got 2 points. One is Pascal's law, another one is buoyancy force equation. So from here, next onwards, we will get Archimedes principle and all this. So we will discuss in our next class, but be ready for this equation. Now you will call this equation so many times like how you call pressure, rho Gh, now buoyancy force, dlvg. So V is volume of the object within the liquid. G is acceleration due to gravity. dl is density of the liquid.